Objective, adding and subtracting scientific notation. Vic number 1, if you move the decimal to the left, then add to the exponent for each place that it has moved. Example number 1, 1,243 and 56 hundredths times 10 to the 0 power. So 10 to the 0 power is just 1, so this is our base number. And if we move the decimal one place to the left, then we're going to add 1 to the exponent because we move one place, so 0 plus 1 is 1. If we move this decimal 2 places, so now it's between the 2 and the 3, between the 2 and the 3, then we go from 0, move 2 places, so add 2. 0 plus 2 is 2. So we're going up by 1 each time in our exponent for each place that the decimal moves. So from between the 4 and the 5, it moves 1 place, so our exponent goes up. It moves between the 3 and the 4 to between the 2 and the 3, so our exponent goes up by 1 more. Now our number is in scientific notation because we only have 1 digit in front of the decimal. So if you look at the original, it needs to be between the 1 and the 2, so we move it 1, 2, 3 places, so 0 plus 3 gives us 3. Example number 2, 9,864 and 2 tenths times 10 to the 5th. So this number is not in scientific notation because the decimal place needs to be between the 9 and the 8. So we have to move it 3 places to get there. Our original exponent was 5, so we add 3 to the 5 because we moved 3 places. 5 plus 3, now our exponent is an 8. Our number is in scientific notation because we only have 1 digit in front of the decimal place. Example number 3, 10,005. Now you don't see the decimal, but it's after the 5. It's times 10 to the 2nd power. So we're going to move the decimal until it's between this 0 and 1. So we move the decimal 1, 2, 3, 4 places. Since we're moving to the left, we're going to add to the exponent. It was 2. 2 plus 4 for the places that we moved gives us 6. So our new exponent on our power of 10 is 6. Vic number 2, if you move the decimal to the right, so in the opposite direction this time, then subtract from the exponent for each place that is moved. So when we go to the right, we're going to subtract. Example number 4, we have our decimal here, 0.00657 times 10 to the 0 power. So tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. This is 657 hundred thousandths times 10 to the 0 power. So again, 10 to the 0 power is just 1. This is our base number. If we move our decimal 1 place to the right, now it's between these 2 zeros. Now this 0 still over there, but we don't need to write more than 1 0 in front of our decimal. So we've moved it 1 place to the right, so we subtract from the exponent 1. 0 minus 1 gives us a -1 exponent. For every place that we move our decimal to the right, we subtract 1 from the exponent. Subtract 1 from the exponent. So now it's between the 6 and the 5. Only 1 digit is in front of the decimal place. So our value in scientific notation is 6 and 57 hundredths times 10 to the -3rd power. If you look at our original, to get this decimal between the 6 and the 5, we have to move it 3 places. Since we moved it to the right, our exponent is going to be -3. This number is smaller than 1. Example number 5. We have 0.00168 times 10 to the -7th power. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So this is 168 hundred thousandths. So it's to the -7th power. you can see that we have to move the decimal 3 places to the right, which means we're going to subtract from the exponent. Subtract 3 for the 3 places we have to move. -7 minus 3 more gives you -10 as our exponent. Notice that we only have 1 digit in front of the decimal, so this is in scientific notation. Example number 6. 47 thousandths times 10 to the 4th. So we have to move this decimal 2 places to get it between the 4 and the 7. So now there's only 1 digit in front of the decimal. Since we moved 2 places to the right, we're going to subtract 2 from the exponent. 4 minus 2 gives us 2. 4.7 times 10 to the 2nd power is in scientific notation. Only 1 digit is in front of the decimal. Vic number 3, if the exponents are different when adding or subtracting, change to the largest exponent. So if we have 10 to some power and we need it to get bigger, we're going to move to the left. If we have 10 to some power and we need that exponent to get smaller, we're going to move our decimal place to the right. So move to the left to get bigger and move to the right to get smaller. And subtracting scientific notation with the same exponents. So in these 4 examples, you will see that they all have the same exponents. 2 and 2, -4 and -4, 5 and 5, -3 and -3. These all have 10 to the same power. Alright, example number 7. In order to add scientific notation, we need to have the same exponents. And since in these 4 problems we already do, it makes it easier for us. So we can take 9.89 and 6.25 and we can pull those out and add them together. Times 10 to the 2nd power. We keep our exponent the same, times 10 to the 2nd power. So in your calculator, you can type in 9.89 plus 6.25, and you should get 16.14. 16 and 14 hundredths. Carry down the 10 to the 2nd power. Now this is not in scientific notation, because I have 2 digits in front of the decimal instead of just 1. So I need to move my decimal 1 place to the left, so it will be 1.614 times 10 to the, now that we move the decimal to the left, remember if you're moving to the left, then you are going to add to the exponent. So it was 2, so 2, and we moved it 1 place, so 2 plus 1. For our exponent will give us 1.614 times 10 to the 3rd power. This is our answer. Example number 8. 5.64 times 10 to the -4th plus 2.162 times 10 to the -4th. So again, we can pull out these pieces and add them together. Carry down the times 10 to the -4th, the exponent doesn't change here. Add these together on your calculator. And you should get 7.804 times 10 to the -4th. Now, is this number in scientific notation? Only 1 digit is in front of the decimal, so we already have our number in scientific notation. Example number 9. 7.09, or 7 9/100 times 10 to the 5th, minus 1 2/100 times 10 to the 5th power. So just as we did when we were adding, we can pull these numbers out and subtract them. 7.09 subtract 1.02 times, keep the exponent the same, 10 to the 5th power. Type this in your calculator, 7.09 subtract 1.02, and you should get 6.07 times 10 to the 5th power. Check to make sure your number is in scientific notation. It is. There's only one digit in front of the decimal, so this is the final answer. Example number 10. 8.2 subtract 7.52 times 10 to the negative 3rd power. Keep the exponent. 8.2 minus 7.52. Again, go to your calculator. So we have 0.68 times 10 to the negative 3rd power. Now, this number is not in scientific notation because I need a digit other than 0 in front of the decimal. So I need to move this decimal one place to the right. So now my number will be 6.8 times 10 to what power? Well, it was the negative 3rd power, and since we moved to the right, we must subtract from the exponent. We moved the decimal one place, so we subtract 1 from the exponent. This gives us 6.8 times 10 to the negative 4th power. Our number is now in scientific notation. Adding and subtracting scientific notation with different exponents. So we have 5 as an exponent and 6 as an exponent. We need them to be the same. Vic number 3 says that we're going to change the smaller one to make it equal to the largest exponent. So this 5 needs to become a 6. Well, if we need the exponent to get bigger, then we have to move the decimal to the left. So I need this number to become a 6, so I have to move this decimal one place to the left. From 5 to 6, there's a difference of 1. So now my number will be 0.752 times 10 to the 6th plus 2.82 times 10 to the 6th. Now that these have the same exponent, I can add them just as I did in the previous examples. So 0.752 plus 2.82 times 10 to the 6th power. Go to your calculator, type these in. You should get 3.572 times 10 to the 6th power. This number is in scientific notation, only one digit is in front of the decimal. Example number 12. Negative 17 and negative 18 are my exponents. Negative 17 is bigger than negative 18. Okay, now if they were positive, it would be reversed, but since they're negatives, remember negative 17 is closer to 0 on our number line, so this is the bigger one. I need this one to increase by 1. So in order to increase, we need to move the decimal to the left. In this case, we're going to move it one place to the left. So this number will become 0.314 times 10 to the negative 17th power. This one stays the same. Now that they have the same exponent, I can add them together. 9.782 plus 0.314 times 10 to the negative 17th power. Add these together on your calculator, and you get 10.096 times 10 to the negative 17th power. This is not in scientific notation because I have 2 digits in front of the decimal and I only need 1. This decimal needs to move one place to the left. Remember that when you move to the left, the exponent gets bigger. We add 1 to the exponent when moving to the left. So it will be 1.0096 times 10 to the negative 16th power. And the negative 16 comes from negative 17 plus 1 because we moved our decimal one place to the left. Example number 13. All right, we have negative 5 as an exponent and negative 6 as an exponent. Negative 5 is bigger, so we need to add 1 to this exponent, which means we have to move our decimal 1 place to the left. This number stays the same. We're subtracting 0.79 times 10 to the negative 5th power now. We've made our exponents the same. Now we can subtract 8.41, subtract 0.79 times 10 to the negative 5th power. Remember, we always change our exponents to be equal to the larger exponent, and negative 5 is bigger than negative 6. You can subtract 8.41 minus 0.79 on your calculator, and you should get 7.62 times 10 to the negative 5th power. This number is already in scientific notation because I have 1 digit in front of the decimal. Example number 14, our last example. 5 is an exponent and 4 is an exponent. The 4 needs to be a 5. To go from 4 to 5, we need to increase by 1. So I'm going to move the decimal 1 place to the left. Remember, when you're increasing, you need to move the decimal to the left. So I have 1.33 minus 0.49 times 10 to the 5th power. Remember, we keep the larger exponent. Subtract these, and you should get 0.84 times 10 to the 5th power. Now, this number is not in scientific notation, so we need to change it. We need to move the decimal 1 place to the right. Remember, when you're moving to the right, you're going to subtract from the exponent. I moved the decimal 1 place, so I must subtract 1 from the exponent. 8.4 times 10 to the 4th power. And you're finished.